Says here to say hello. Hello, I'm Anya, and this is my friend and colleague, Silver Oliver. I'm going to do the first half of this talk. I'm a librarian. So I'm going to start with a brief explanation of what the House of Commons Library does, who works there, and who we're working for. So first of all, it's not entirely that kind of library. That is the House of Commons Library, one of the rooms, but we're really a research library. So we have books, but mostly we answer questions. There's 200 of us, 65 librarians, and 110 researchers, which is a weird balance if you're thinking library. So to explain why we have so many researchers. First of all, because I'm in government, I need to say Parliament is not government. We're not a government department. So Parliament's job is to scrutinise. Sorry, I get really nervous speaking. Sorry. Parliament's job is to scrutinise government. And we're made up, the membership of the House of Commons is made up of ministers. So I think you think of members as being from a party or different parties. But it's another way of looking at it is you've got ministers, they won and they got a job. You got backbenchers, they won but didn't get a job. And then you get all the opposition as well, right? And to do their job, they have to answer questions. They need information. These guys, the ministers, they've got the civil service. They answer the questions. The library levels the playing field. So we answer the other people's questions. So these are the kind of questions that we get. Our member of parliament will be thinking about a particular constituent, one person with one problem, or they might be thinking about everyone in their constituency, or they might be thinking about a national policy, or they might be thinking about a global policy, or they might be thinking about their spot on TV that night. So we have to be ready to answer all of those questions. So that's who and who works there and who we work for. I'm going to talk about one of the services. Sorry, that's a Wardley map. This is a Wardley map of the request service. So you've got the sort of y-axis is like the visibility of the components. The x-axis is how novel something is to how commodity something is. And these are all the components that go into our request service. And we've got an inquiry comes into the front of house librarian and it gets routed. We're looking for a researcher who's going to answer this question. And then we've got all the tools that the researchers need to answer the questions. So we've got a case management system for inquiries. We've got information services like parliamentary search or current awareness, the library catalogue. We've got research briefings. They're kind of commodity answers to questions. They get asked a lot. So let the specialist write a briefing and publish it. Yeah, that's kind of it. A thesaurus. I'll get onto that. This is the same map, but those blobs highlight where subject indexing takes place. Because the nice thing about the House of Commons Library is they didn't fire the librarians. We've got lots of librarians and we still manually subject index all the things. So all of those places is where subject indexing is happening, but really annoyingly, they're not using the thesaurus. So we've got a thesaurus. All of those different systems are using slightly different versions, different taxonomies, all forked, differently managed. I think research briefings is actually free text. Be bad. So the thesaurus, that's a really unsharp picture. What is it? We've had it since 1979. We look after it. It's got 140,000 concepts in it, different concepts, people, organizations, that kind of thing. And why it's useful. I'm talking to IAs, you should know. It's got stable identifiers, so when labels change, it doesn't break, it's interoperable. We've got synonyms, so your bird flu, my avian influenza, still works. It's got hierarchy, so you can use the transitivity to answer your questions. And it responds to change, because we look after it day after day. I'll say the fifth thing is librarians, who you can't make out because they're really shy, but they're right at the back. So the project that we're working on with Silver is simple, which is wherever subject indexing happens, we want it to use the thesaurus. Really simple. And this is where we're coming from. Different things which are subject indexed, but siloed. I should say they're not siloed because the people who look after those things are narcissists. You know, they didn't think we can do it better than those guys. There's no piping. There's no system to get the thesaurus to those systems. And this is where we want to get to. A subject-centric knowledge graph, greater than the sum of its parts, it says here. Yeah, we want to move away from fighting against the plumbing. And this, happily for me, is where I hand over to Silver. Thank you.
Thank you. I guess most of this talk, it feels like the same talk we could have given 10 years ago. And so the fundamentals look very similar and unprofound. And I think the thing that's interesting here is actually the maturity of information architecture and how do you move it down into an organization. So quite often we're talking about surface, and as information architectures, we're designing information spaces, which we're almost stapling together at the end of the process. So the major change, I think, for Parliament is the collaboration between information architecture and the librarian capacity, and then how do you start to move that into the organization, into key business systems, and that takes years. And the reason we're showing you Wardley maps is to reflect that state of change and how at the surface level, we've got sort of the information architecture that people see, and then you actually see the business systems that over time need to change and align. And what we want to do is have more and more of these component parts built in a way that they're part of a coherent information architecture. So how do you get that information architecture reflected? And that really means end-of-life systems being commissioned and replaced in the right way. So lots of the themes and the stuff that we're doing is about how do you commission and design things in the right way. And I think another thing that's changed recently that really helps is we've got frameworks like FAIR and data mesh, which from a technology point of view are pushing for some of the same values as information architecture. So for instance, with FAIR data, essentially it says, here's the guidelines for a data product and here's the principles you should follow. So for instance, in terms of FAIR, it says, make sure that your data is well described, well modeled and machine readable. And then once you have that data, make it accessible in ways that other people can use and build upon. So you're not just recreating the same data sets and forking the vocabulary continuously. Interoperability is obvious. It's about control vocabularies and good IA principles. And then the reusability here is that if we do these other parts, as we build and commission new parts of this system, that we're able to build on existing systems, do the right thing rather than just have to build a new system in a silo, which is kind of what Parliament's been plagued with for years. So it's really about how do we take an information architecture and over time make that part of the sort of core principles of the organization. And the result of that is then we start to end up with this coherent information architecture on the surface for users. It means time to value becomes quicker. It means we're reusing the good work that we're already doing and leveraging things like the thesaurus. Some other familiar techniques that we've been talking about for years and years and years haven't changed. Domain-driven design. So lots of the work here is actually less about technology, and as technology becomes more and more commoditized, it feels it's less about lines of code and more about optimizing for learning and how do we emphasize that learning bit when actually sort of the measure of lines of code in terms of success of a project is becoming less relevant. And domain-driven design is there because as we start to design information spaces, inevitably we are laying that over an organization that looks something like this. Essentially, you've got groups of people who know about one thing, some diverging opinion here, something else only one person knows about. And the insight from domain-driven design is actually that that design, that development of shared language should be a shared exercise. And then there's all sorts of things around drawing back at each other and how easy it is just to hold up a model as the information architecture and say, here it is, do you agree with it or not? And that's a shared responsibility, and it's only when you start drawing back at each other, you start to understand where your differences are. So I think someone was asking about the importance of a single IA. I think there's an element here that lots of the success we've had at Parliament has been about distributing the responsibility for that shared language and shared understanding of the models. So as people go away and design UI or design databases, you're coming from a shared information space. And this is our domain model for single subject view. So this is now responsible for what the subject finder has always been. So when Anya was talking about an MP going to ask a question, essentially what has existed for the last however many years is this book. So basically, if someone asks a question about dangerous dogs, you flick through here, you find something that looks like dangerous dogs or animals, and then you'll find a directory number to contact a specialist. What we're now moving to is obviously a digital version of that and some AI. But I think one of the really interesting insights has been that we weren't sure if we're going to continue creating this or not, but the overwhelming response has been, this is still really important. And I think the element there is that as you join as an MP, this goes in your tote bag on your first day. And the problem with giving people Google-like search boxes or ChatGPT search boxes is obfuscates the information space. And in that case, you just go and type into Google instead. By having this, it's almost like the contents page of a book. You're laying out the information space, setting out your stall. It's not the best way to find it, but actually, if this goes away, people just stop using it anyway because they don't know what to anticipate. So I think we see there's a whole spectrum of how this then gets exposed, both in physical artifacts, search boxes, browsable spaces, and chat as well. But actually, they're all complementary and really important to serve different user needs. Oh yeah, and here we go. Okay, so we're going to continue printing this, and this will be something we can export from the data and recreate this. We can then also leverage the taxonomy, so we've increased the surface area. So not just animals, we've got all the things in the hierarchy now. But someone can search for dangerous dogs and go to the dangerous dogs page, and a slightly more intuitive routing for the thing that you're asking your question about. That will take you to your dangerous dog page. Previously, we just had specialists, but we also have briefings there. So if we've already got some pre-answered questions, we can sort of anticipate the routing there, and someone can get the briefings information. In this case, dangerous dogs, we don't actually have specialists or publications, but then we go up the hierarchy and say, well, we can give you specialists for animals. Next. Oh yeah, and then we got our individual specialists that you can navigate to, and then you can just call them on a Teams call and things like that. But information space, search boxes, physical artifact, and then also inevitably the ability to use AI as well. So I think we just see this as an extension of the work. So we are using sort of RAG techniques here, but the important things here are privacy, because these are MPs' questions where they're identifying things they are interested in and inquiring about. So privacy is really important. Latency is really important because we have current awareness. And as you can imagine, these questions are obviously in a response to an event that's happening. So minutes, and then explainability as well. So the way this is working from our knowledge graph is that we are only passing through a subset of the data to a private large language model, so it can only be constrained and work on what, so it's really doing just sophisticated summarization, nothing more than that. What's kind of interesting is that when you ask it for an expert, because we haven't at the moment given it the context of what we specifically mean by an expert, it chances its arm a little bit and does what might feel intuitive, which is find experts associated with briefings. So someone who's written a lot about housing historically, you might want to speak to them, but that's very much not how expertise work as people move around. It's also done things like questions about railways, suggesting you go and speak to Mike Lynch about a certain question. So obviously this interaction between what dials do you have as an information architect in terms of prompt wrappers and embedding to start training and give context so it reflects how your service works and sort of, you understand the world. Oh, and then this is just a list of outcomes, which is just generally about, the information architecture permeating through the organization is a lot more than just the user experience. It's about goes into data governance, accountability, making more of the things we already do and saving time and costs. So there's and that's us. And then there's reading list. Thank you.
Dan's question at the bottom.
I think it's on, yeah.
The taxonomy kind of is available, but I'm not going to give you the URL because it's terrible, terrible website. Hopefully, properly, we are going to upgrade the application that we manage it in over the coming year. But even though I'm complaining about it not being plugged into enough things, it's plugged into so many things that upgrading it's going to be a complete nightmare. So we expect it to take maybe a year, but we would hope that we'd have a public API. We do stick all our identifiers into Wikidata, though, and store their identifiers in our system too. So that, yes, I think I can see that being available. The knowledge graph thing, I'm not sure, because we're so focused on solving that MP problem, that privacy problem. I don't know. I feel a bit weird about putting AI over Parliament's website and sort of saying, here, you can trust this to interpret what an MP said. I don't think that's our job. I just wouldn't want to touch it. No.
We have a question from Sally. I think, yeah, just checking if there's any other hands, but yeah, Sally.
Yeah.
How would you go about getting senior buy-in for something like this? Because often the hidden data layer is not invested in, it's the AI product on the top. So have you got any tips for people?
Patience. I think when we've been banging on about this for about 10 years, but I think we wrote the first sort of business case and did the prototype 4 or 5 years ago, 4 years ago. And then it's another, okay, we're interested. And then you go through it again, another business case. I think the procurement took over a year to get this project done. So it's kind of patience. And yeah, there's no, they still don't know what we're doing. Yeah. Yeah. Do you want to do?
Was there?
That's not for us, is it? The AI?
Just on that buy-in, I guess the thing we noticed is there's an autonomy small thing, isn't there, about getting people to pay for the plumbing,
Yes.
and that's really hard. So I think this project's been a bit under the radar, but now with AI, data mesh, and FAIR, suddenly it's senior management. It's sort of, this is the stuff we should be doing, and then realizing it's sort of yeah.
They think it was their idea.
Yeah. Yeah.
Amazing. So we have one more talk before we get to the break, more refreshments and things like that. Bear with me while I do a little bit of tech faff, but up next is Imogen Levy. Hi, Imogen.
Hello.
I'm going to take over and share your screen. Imogen's been working in healthcare IA and product for at least more than 10 years, and is now working on some super juicy stuff at NHS England.
Am I loud and clear?
All good?
Awesome. So, hello. I did have a view of the audience earlier, and I recognised some faces. So, hello, Amanda, who's sitting in the second row. My name is Imogen Levy. I would really have loved to have been there, but I am nursing a bit of a chest infection. So, apologies if I have to cough a lot. I thought it was best to just be at home for this one. My role is head of product for a program called First Contact, which is a relatively new program in NHS England. And our focus is on rethinking how people access healthcare, ensuring that patients are guided to the right care at the right time in the most efficient way possible. Now, this year's World IA theme of challenges of change, I think is particularly relevant to healthcare. Change in this sector is constant and complex, driven by evolving patient needs, digital transformation, and increasing pressure on services. In this landscape, traditional information architecture, like static hierarchies or predefined pathways, are really no longer sufficient. Like, we must find new ways of thinking, leveraging AI and dynamic systems to help patients access care seamlessly and ensure that healthcare navigation is future-proof. Healthcare is one of the most critical services in society. It affects every single person at some point in their lives. And yet, for many, the reality of accessing healthcare can feel overwhelming, frustrating, and at times impossible. For years, information architecture has focused on structuring and organizing information so that users can find what they need efficiently. In many domains, this works really, really well. Online shopping, where structured categories guide users to what they need. It works for libraries, where books are categorized to be easily searchable. But what happens when a structured system is no longer enough? What happens when the complexity of real-world decision-making outpaces a static framework? That's exactly what we face in healthcare. The NHS is a vast and vital system, but it's often difficult for patients to navigate. Too often, they don't know where to go, they don't know who to contact, and when they finally do, they face bottlenecks and delays. So the question we need to answer are, how do we make accessing healthcare as intuitive as possible? How do we design an experience where the right care is always within reach? And how do we shift from a system that puts the burden on the patient to one that actively supports them? Now, these are the questions we're tackling in our work stream, which we're calling intelligent navigation, which is really about a new approach to guiding people seamlessly through NHS services, leveraging AI, real-time data, and human-centered design principles. Today, I'm going to talk through why traditional healthcare navigation is broken, how intelligent navigation aims to solve these challenges, and how AI and information architecture can work together to create a model for accessing healthcare. This isn't just a technical upgrade, it's a fundamental shift in how people experience healthcare. Imagine it's the middle of the night and you or a loved one start experiencing worrying symptoms. Your mind starts racing. Is this something serious? Should I wait until morning? Should I call 111? Should I go to A&E? You pull out your phone and you search online. You find advice, but it's not specific to you. NHS 111 is an option, but you've heard mixed reviews about how helpful it is. A&E seems like the safest bet, but you know you could be waiting for hours. You want someone to just tell you what to do. This isn't just a minor inconvenience, it's a major failing of the system. Confusion about where to go leads to delayed care, unnecessary visits to emergency departments, and increased pressure on already overstretched services. And it's not just about emergencies, routine care is also fragmented. Booking a GP appointment, accessing physiotherapy, or finding mental health support should be seamless, yet is often frustrating and inconsistent. Today, the burden is on patients to understand how to access their care in the right way, but the data shows the system isn't working efficiently. 1 in 3 GP contacts could be handled by other services. 40% of A&E visits could be treated more appropriately elsewhere. 30% of patients struggle to get hold of their GP, causing delays. And 40% of NHS 111 users are redirected back to primary care, often getting stuck in a referral loop. These numbers highlight systemic inefficiencies that impact both patients and providers. But let's break this down further. First, why are so many patients going to the wrong service? For many, it's simply the easiest or only option they know. If a GP appointment isn't available, the next step is often urgent care or A&E. Many people don't realise pharmacies can provide clinical advice, or that certain conditions can be accessed through digital triage. Second, the referral loop issue. A patient calls NHS 111 only to be told to go to their GP. Their GP phone lines are full, so they're redirected back to 111. The endless cycle delays treatment, frustrates patients, and increases demand on an already overburdened system. This is not a system designed for efficiency. It is not designed around the patient experience. Instead of supporting people in making the right decision, the system forces them to figure it out on their own. We need a system that removes these barriers, one that doesn't just present multiple options, but proactively guides patients to the right care at the right time. That's where intelligent navigation comes in. Navigating the NHS should be straightforward, but in reality, patients face a maze of choices. Many don't understand the difference between services, and each interaction feels like starting over again. Patients get looped, causing delays and frustration. They lack clear direction, leading to unnecessary A&E visits because it feels like the safest option. Each interaction requires patients to repeat their symptoms, adding friction, frustration, and inefficiencies. This isn't just inconvenient, it has real consequences. The lack of integrated real-time guidance forces patients to make complex healthcare decisions without the right tools or information. They need more than just a list of services. They need clear, actionable guidance that helps them to the right place first time. This is why we need a solution that removes complexity, reduces patient stress, and ensures the NHS works smarter, not harder. Traditional information architecture relies on fixed hierarchies and structured pathways. In many industries, this approach works well, but in healthcare, static systems create unnecessary friction. Static IA assumes a one-size-fits-all pathways, failing to account for the complexity and urgency of individual cases. Patients are expected to navigate services on their own, often without the necessary knowledge or support to make informed choices. Information is not personalized, meaning that a young adult with minor symptoms receives the same options as an elderly patient with complex medical history. There is no real-time adaptation. Service availability and patient-specific risk factors are not factored into navigation. Healthcare is not a simple lookup system. It requires adaptive, AI-driven guidance that considers patient history, symptom severity, and real-time service availability. A true effective system would guide patients dynamically based on their personal context, adapt recommendations in real time, considering available capacity and clinical urgency, reduce decision-making on patients, ensuring they reach the right care first time. Intelligent navigation changes this by embedding AI-powered dynamic triage directly within some of our national NHS platforms like the NHS app, ensuring a seamless guided journey for every patient. Current navigation systems present multiple disjointed entry points. What we're trying to do is create a single AI-powered system that creates a single digital entry point within the NHS app, ensuring a consistent experience for all patients, no matter where they start. The system will guide them automatically. Intelligent segmentation, so patients are routed based on medical history, symptom severity, and risk factors. Real-time service availability integration. The system considers local capacity to direct patients where care is most accessible. Direct booking and follow-ups. Instead of vague recommendations, intelligent navigation schedules appointments directly. And by aligning demand with capacity, we can create a system that works smarter, reducing inefficiencies and stress for both patients and clinicians. The transition from traditional fragmented healthcare access to intelligent navigation represents a real step change in how people access and experience care. Instead of forcing patients to self-navigate disconnected options, intelligent navigation provides proactive guided care that meets their individual needs. Patients no longer have to guess where to go. Instead of searching multiple websites, calling different services, or waiting in long queues, they receive clear communications tailored to their symptoms, medical history, and location. Real-time decision-making ensures faster, safer access to care. Instead of manually assessing their situation, Patients benefit from AI-driven triage, which dynamically adjusts based on urgency, availability, and risk. Imagine this: a patient wakes up in the middle of the night with severe stomach pain. They don't know if it's something serious, and they're unsure of the next steps. Instead of searching, they open the NHS app. The system checks their medical history and factors in that they have recently had minor surgery. Based on real-time demand, the app determines the next best course of action, whether that's a virtual GP consultation within the hour, urgent care, or self-management guidance. If needed, the app books the appointment instantly, integrating with local services to ensure a seamless experience. For the patient, the process is simple. For the NHS, it means reduced pressure on urgent care, better resource allocation, and faster access for those who need it most. Using patient history and symptoms to enable better navigation is the hypothesis that underpins the work that we're exploring, ensuring that individuals are directed to the right service from the start, reducing unnecessary referrals and improving patient outcomes. We propose a unified model where patient symptoms and medical history are taken into account from the very beginning, enabling a more accurate triage decision. This is moving from a system where patients must choose between multiple access points with little guidance or interaction to a single coordinated navigation system that directs patients to the right care immediately without unnecessary delays or handoff. The current NHS navigation system treats all patients as if they have the same needs and challenges. But we know that healthcare is not one size fits all. Patients present with different levels of complexity and their care needs vary significantly. A more tailored approach is required to reduce those bottlenecks and improve care pathways. But understanding the different levels of complexity that a patient experiences is really key. And we've broadly divided these into sort of the RAG status here on the screen. First one is complex. These patients generally have long-term conditions, multiple health issues, or ongoing care requirements. They need continuity of care, meaning that they require consistent access to the same clinicians and specialist teams. Current systems often fail them by forcing them into generic triage pathways that do not recognise their established care plans. Intelligent navigation ensures they are identified early and routed appropriately, maintaining their access to integrated care teams and avoiding unnecessary delays. Medium complexity. These patients might have some pre-existing conditions that are relevant to their current symptoms, but do not require specialist interventions every time. Navigation must consider medical history and risk factors when directing them to the right care. For example, a patient with high blood pressure experiencing headaches might require a GP assessment rather than being directed to self-care. And non-complex patients, these are otherwise healthy individuals who present with self-limiting conditions that do not require GP or hospital intervention. The current system often directs them to GPs unnecessarily, taking up valuable appointment slots. With intelligent navigation, these patients can be safely guided towards self-care, pharmacy consultations, or digital advice, reducing strain on an already overstretched service. Why does this matter? Undifferentiated pathways lead to bottlenecks. If all patients are funneled through the same triage and referral process, urgent and complex cases are delayed, while simple cases consume unnecessary resources. So rather than forcing all patients through the same triage model, intelligent navigation applies dynamic, personalised decision-making. To create an effective, scalable and patient-centred system, we've got to balance national strategy with local flexibility. Now, our approach is designed to ensure that every region has the ability to tailor navigation models to their unique needs while maintaining a consistent experience across the NHS. Healthcare demand varies significantly from one region to another. Local NHS systems need the ability to shape navigation models that work for their populations. But while local customization is important, patients should experience a unified journey regardless of where they are. The NHS app serves as the central digital entry point, giving patients a consistent experience. AI-driven navigation integrates across national digital channels, ensuring every patient has access to the same high-quality triage and guidance. A one-size-fits-all will not work. Regions must be able to configure those navigation models to their specific healthcare landscape. However, we must find a balance and ensure consistency, safety, and quality for all patients. We're currently scoping some regional pilots across multiple NHS locations, and these pilots are designed to evaluate which capabilities provide the most value. So this is about testing different approaches to digital triage, symptom-based navigation and integration at a local level, assessing the effectiveness of real-time service availability in reducing unnecessary A&E and GP visits. We will be assessing real-world impact before scaling nationally. Pilots provide us with an opportunity to collect data-driven insights on patient behaviour, system performance and clinician feedback. We will be tailoring the system to different NHS regions, so no two NHS regions are the same. Piloting allows us to test the system across a variety of different settings, including urban and rural areas, high-demand hospitals and underutilised community services. As part of our initiative, we will be piloting 2 models in London to test how AI-driven triage and streamlined digital navigation can improve patient outcomes and optimise resources. The first pilot objective is to evaluate whether AI-powered triage enhances assessment accuracy, increases clinical productivity, and ensures more appropriate service users for non-urgent patients. The second pilot, that's our second pilot, sorry. Our first pilot objective is to test whether reducing the complexity of triage questions in the NHS app leads to better patient guidance, reduced demand on urgent care, and improved access to GP services. Sorry, I'm whistling these. I'm conscious that you want to have a break, and I've just got a couple of slides to finish. So as we develop and implement our approach, we are committed to a set of core design principles that ensure this approach is not only effective, but also sustainable, patient-friendly and aligned with NHS priorities. We will lean on the knowledge and existing capabilities of local systems, prioritising the efficient reuse of capabilities before we build or buy anything new. A key challenge for us is identifying what we should be owning and supporting and building nationally versus locally. That's a real challenge for us as we embark on this project. However, we will remain focused on validating our hypothesis, as I've laid out, and being evidence-led as much as possible. The success will be measured by real-world impact on patients, clinicians, and the NHS system as a whole. Our approach is designed to drive measurable improvements in healthcare access, efficiency, and patient outcomes. We are working across a very complicated and fragmented system. These are just a number of the organisations, suppliers and providers that are involved in scoping some of the work that we'll be doing. And we are working with NHS England, integrated care boards, digital partners, frontline clinicians, patients, everyone. There's a huge amount of stakeholder wrangling that's involved in this project. As we look ahead, it's clear that intelligent navigation isn't just about an improvement to technology. It's a transformation in how people experience healthcare. Healthcare navigation has long been a challenge, with patients left to figure out their own path through a complex and overwhelming system. By applying the principles of adaptive information architecture, AI-driven triage, and patient-centered design, we have an opportunity to create a system that guides, supports, and empowers people rather than leaving them lost in uncertainty. By working together across policy, technology, clinical practice, and user-centered design, we can fundamentally change the patient journey and make healthcare access seamless, intuitive, and fair for all. Thank you for letting me come today.
Thank you, Imogen. We'll take just one question from Slido before moving to the break. It's been a lot of content, but definitely time for some refreshments and a break. After the question, we'll come back at past and get into Mike. There's a lot of good questions for Imogen, but top of the list is from Dan. Dan says, I'm sold, Imogen. How do we get NHS leadership to invest in something so utterly sensible as dynamic IA? To borrow from Anya, how do you make it their idea?
Ooh, that's such an interesting one. I love that question, and I think it's something that I think about every day. And now we've had to go on a bit of a journey with this as a team. We were only created this time last year, and we've gone from kind of nothing to like really driving a sort of key strategy in partnership with the system. Now that is the absolute key point that I want to sort of bring up here, that we couldn't have done this or driven the strategy behind this without key sponsorship and doing this in partnership with kind of local systems. Now, I don't know what it is where you work, but where we work in NHS England, we have this concept of like the centre and sort of national. Now, NHS app is seen as sort of a national product, but actually the real innovation and the real work is done at a kind of local level or local systems. Now, local means lots of different things. So we're split in so many different ways in the NHS. But the trick is bringing together kind of national digital capability, skills, resources, insights, expertise with local systems. Those are where the problems are. That's where we need to really focus our attention. And so I think the success has been on finding where those partnerships are, and at the same time, doing a really good job of kind of selling a vision and bringing people on board. I've spent the last year trying to do that and drumming up interest and having sort of senior sponsors. So finding where those advocates are, finding where there's opportunity to partner and go to where the real problems are.
Excellent, thanks, Imogen. There are some really good questions in Slido. If people want to reach out to you, they can contact you through LinkedIn.
Yeah, absolutely. Yeah, please do.
Awesome. Cool. A big hand for Imogen, and let's break. Let's come back at past. It's pretty hot in here. If you need any drinks, we've got some mugs tucked away and we can get stuck into the taps. Let's go back to the seats for our last talk with Mike Atherton. Back to the seats. Back to the seats. Do some shepherding. Shepherding.
I need a wee.
Roll up to the next talk. Next talk. Awesome. Next talk.
No, you shouldn't.
You will for the barriers. It's like just on the barrier bit, yeah. And if something goes,
I don't
yes.
need a card.
No, you should be fine getting out. I might have to tap you out. Actually, you're fine because actually no, I need to do it. Never be too careful. But after this, yeah, you should be fine. No worries, thanks. Excellent. Cool. Without further ado, Mr. Mike Atherton.
Thanks, Rick. Hello, everyone. Well, they say you play World IA Day twice in your career, once on the way up and once on the way down. It's good to be back. And kind of fitting, actually, because the last time I was here was in 2016, when the closing talk of the night was by Mr. Paul Risson, who's in the audience tonight, when he talked about story webs, which is something that we're going to be looking at tonight. Even then, he was drawing on ideas that go even further back, which we'll also touch on. But tonight, this is all about how we're going to bring some of those old ideas back to life with the power of AI and IA. So back in the mid-2000s, domain modeling was the thing at the BBC. It was quite the vogue in IA, and it seems to be still tonight. All about slicing content into semantic chunks, connecting it by meaning, not just by container. So we wanted to reveal the connections and create new user journeys, truly a creative act of information architecture. It was about structural creativity and designing revelation, if you will. The BBC Mythology Engine prototype took this further in 2010. Applying domain modeling to drama. So we wanted to model out, or the team wanted to model out, not just facts, but stories themselves. Things like Doctor Who, but also EastEnders and the Archers. Could their narrative architecture be mapped? Could characters and events and the relationships between them be properly modeled and represented online? So Tristan Fern and team built a prototype website to explore this, aiming to unlock deeper ways to navigate and understand these rich fictional worlds. And my old buddy Theo Jones remember that bit. Beautiful design work by Theo there as well. You get the idea what the Mythology Engine was there to do. Hello, I'm Mike, and I've been working with managed content for about 30 years. You may remember me from the book I wrote in 2017 with Carrie Hain. You probably don't remember me from Newsbang, the AI-generated podcast I ran for 366 consecutive days last year. Truly AI comedy's finest hour, spread over about 150 hours of content. Last 20 episodes, pretty good. So I've been diving into Gen AI as truly a creative medium. Like Paul, I also see sort of IA as a creative medium, and it's one thing to kind of deal with, you know, enterprise knowledge graphs and what have you, but I think we can still apply a lot of those that thinking to more fun, more creative, more fictional things. So let's do that. And quickly, let's just hear from Paul back in 2016. What did he say? He said that this video does not automatically play when we click it, and also we can't move the mouse over to the other side of the screen. You got it, Rick's got it. Oh, there he is. Right on. Shut up. Right. Crucial point, isn't it? In stories, the events and character actions are independent, really, of the on-screen chronology. If you think about EastEnders or any soap, really, so much of it happens concurrently, not linearly. So that points us towards a kind of graph structure rather than a linear one. This isn't just about websites, it's about the kind of fundamental architecture of narrative itself. Brings us on to this guy, Russian folklorist. I wish I had that job title. Vladimir Prop talked about the difference between fabula, which was the order that things happen in a story, and sujet, which is the way that we experience it as a reader, as a viewer, whatever. If you think about things like Memento or Back to the Future, or many of the other examples that we'll look at tonight, you can see that things happen in strange orders, and what's happening to the characters is perhaps different to what we see as viewers. So it suggests this kind of graph, non-linear structure, sort of early attempts at the BBC mythology engine. Really the engine behind the website was this kind of stuff, visualized as here, very kind of RDF Tripoli-like complex graph. But the problem was that was all very well for a demo, for a production prototype, but creating these story graphs is really hard. It was, you're having to sort of get into this sort of post hoc, semi-bespoke modeling of each individual story, and that's very time consuming. The content's in the wrong shape. You heard Theo talk about the fact that they had to hire a freelance writer and get all that data generated. The data model itself, because it's such a big effort, becomes kind of a big bet, because you really want to get it right before you're going to go and do all that work. So a lot of big design up front, if you like. Great in theory, but incredibly hard and expensive to scale up or even trial. Because the benefits, as we all know when we deal with sort of knowledge graph type stuff, you really only start to see the benefits when you do it at scale. So then came AI. For my money, LLM is the best thing to happen to content management and information architecture in years. Product managers might sell them as knowledge bases or sort of oracles of reliable information, but they're not, are they? What they are is brilliant token transformers. They're very amazing transformers. They take input, they do reasoning on it, and they turn it into output. So suddenly we've got a cheap and powerful way to extract and even sort of fill in the blanks in content, which is a big market. As Sally and Rich touched on earlier, synthetic data is big business, 3.7 billion by 2030, not just about organizing existing data, but creating entirely new data sets, which can be, if you've got use cases like anonymization, permissible test data, even sort of copyright-free data sets. You're creating net new data from the reasoning on existing sources. So for this World IA Day, I revisited the mythology engine concept inspired by Paul's story webs. And I want to show you something called Fabula, which is a tool to explore this idea of stories as networks. Now, it's Python-based, a bit of code, not pretty, but it uses AI to analyze screenplays or TV transcripts and extract the dramatic elements that we need. And then it aims to represent a story as a connected web of moments from every character's perspective. Let's see how it works. The approach is fairly straightforward. First, we split an episode into scenes, and then we pass each scene through an LLM pipeline for reasoned data extraction. And by reasoned, I mean it can look at the data that's there, and it can also sort of reason about data, which is implicit, but not literally that. So we resolve then all the entities across scenes to ensure consistency, and then finally we output everything as structured JSON. We'll look at that more in a second. Our core tech stack is Python. We're using OpenAI models and a library called BAML, which has been an absolute lifesaver in getting structured output properly out of LLMs. Let's talk schema design. So our principles. Universal, one ontology to fit them all. Many people have tried that crazy idea, never works, but it might work for us. It needs to support continuing stories, so not just sort of looking at a story after the fact and deciding who was the hero and who was the villain, but actually letting the story unfold in real time, as it might with a soap opera. And people are just people who do the things, and then we decide laterally about whether we think they're goodies or baddies. It needs to enrich metadata with reason analysis, and not just sort of raw data in, raw data out. And crucially, it has to support that kind of narrative reconstruction and that fabulous sujet divergence where things can happen in a different order than we see them. And support additional ontologies because, again, we don't want to make the data model a big bet. We want to be able to extract different kinds of things from the same information. So for inspiration, I looked around at some existing drama ontologies. This is a snippet of Onto Media from the University of Southampton. It's actually what the mythology engine was kind of based around back in the day. It's got lots of kind of objects for the things that you'd expect in stories, characters, items, and it's also got these events, and through events, characters can experience gain and loss. There's also this model, Drama, which is an Italian model, actually goes much more internal facing. It's much more about emotions and characters' sort of beliefs and values and goals at that, at any given moment. Using what's called a belief, desire, intention model. So the ideal was some sort of best of both worlds hybrid. And this is what I've gone for. We have episodes and scenes, and then each scene is sort of a bucket of events. We have agents, which is a name for characters, people who have agency in the story, not necessarily secret agents, so sometimes they are. And organizations that they're associated with, locations that scenes take place in, objects that have some sort of significant value. And then we have these sorts of intermediate nodes, crucially, whereby to start with an event, and to connect it to an agent, we actually connect it via a modeled participation. And that's specific to the scene, similarly with objects for their involvements. But we have, the way that agents connect to the event is through a specific participation that's current to that scene. And so what you end up with in the end is an agent profile that has their sort of fixed part, which is their sort of permanent record, but also what's happening to them over time. And that's an attempt to try and solve this challenge that you have in drama, that you've got this kind of time series ontology to model, but things change over the course of as the story develops. Let's see some of this then in action. Flashing images follow. So we're going to start with a screenplay. In our case, typically that's a transcript that we've pulled off the web. And we want to put some structure around it so that we can address scenes individually. So the first part is a little kind of helper script that pulls down that plain text transcript and converts it to structured JSON. Here we're using the Star Trek TNG episode Measure of Man, which is about proving whether an AI has sentience, which I thought was kind of appropriate. And there we go. So that's our script just in JSON. No AI in this bit. This is just kind of regular expressions and converting text into format based on the way that it's structured. Now, one limitation here is that we're going off scripts, not visuals, not video. And so there's so much kind of story context and perhaps rich detail that you would get from those other mediums that isn't literally in the transcript. So we also pass in some story context. We're going to give it a scene, but we're also give it in the back. We're going to kind of slip it the whole story so it kind of knows what's going on when it processes each scene. So here we're actually giving it a copy of the real script, not the sort of the transcript, subtitled transcript, but the real script that's got extra like stage directions and stuff like that in it. That might sound expensive, but prompt caching is your friend. We want to make sure that the model output fits the schema. So we want valid, parsable, structured output that we can further manipulate at runtime. Now, there's many ways to try this. I don't know if any of you have tried getting valid JSON out of an LLM. They say they can do it, JSON mode, and all kinds of asking nicely prompts. Never bloody works. But again, shout out to BAML that just does. It's amazing. So we translate our schema into these class definitions, and the BAML library will make sure that our response from the LLM fits this shape. So here we go. Let's run Fabula. It's going to go through scene by scene, pulling out objects, locations, agent involvements, object involvements, organizations with their member list, and more and more and more. So what it does, it actually has a sort of layered extraction approach. It starts with a scene, it pulls out the primary entities, but then the secondary entities have dependencies, so we need a stable set of primary entities that we've extracted across all the scenes and then sort of normalized into a canonical set. Then we pull out the events that are associated with each scene and we associate them back to the agents and the objects. And then we model out the participations and involvements as a final step. That's bitter experience has gotten to that process. So of course, going scene by scene, we have lots of duplicates that need resolving. We've talked about NER earlier tonight. There's various NLP libraries like Spacey that can sort of help with this to some extent. But a language model can make more intuitive leaps. It knows that Jed Bartlett and young Jed are the same person, even though, you know, a string match would never really find that. Not gonna lie, entity resolution has been the hardest part of this process, and not for any of the kind of normal reasons, just actually making it work in code. But look what we've got. We've got now valid, well-structured JSON that's got all our original dialogue, everything that we wanted to pull out, a full registry of objects, locations, characters, and all the things throughout the story. So we've got a very highly enriched set of story moments. And we pulled all that out for an episode in about 40 minutes of processing time. So yeah, what have we got? We've got every story beat from every character's perspective. We've got all the interactions. We've got their movement from one location to another over the story. We've got their emotions and plans that they change over time. We've got a complete inventory of all the entities. And we can do it for any story as fully modeled content types with unique-ish identifiers and friendly JSON, which is pretty good. So if you had a product like this is Apple's Insight. There's also, you know, Amazon X-Ray. You can imagine that kind of metadata being very useful to synchronize against the live action, or do all kinds of clever stuff with, really. Or, you know, make a mythology engine type website. What we're going to do, however, is think about how we're extract that. Yeah, this is the point I really wanted to make. I mean, we can effectively re-render our content to fit any schema that we want to. And if we do it right, it can happen with very sort of low chances of low error rates, low hallucination rates. And we can actually sort of extract new value and connect new value from existing content. So knowledge graphs then. Neo4j is my graph database of choice these days. It's a label property graph rather than your sort of triple RDF type graph, but it comes with a free desktop client. And so part of Fabula is taking a little post-processing script that turns that structured JSON into a set of cipher scripts, which we then. You see, I wanted to make these graphs available to you, you see, and that's quite hard to do because there isn't really a place you can go and look at like a full-on knowledge graph online. But I made it so that you could, if you had Neo4j desktop, you could paste it in like this, and then you get something like that. All of this information, this is just a part of it, is connected and queryable now through our knowledge base. Truly the kind of story web that Paul prophesized. So throughout this, I've done a lot of testing with real stories and with some lovely AI fanfic written by Claude 3.5. Here's a callback to the Myth Engine demo. They said they had, what, 7 scenes they managed to get. So we did this whole serial in 2 hours. Yeah, $1.45 to get that out. Yeah, I was surprised at that, but and it's pretty good, you know. The stuff that you get in there, it's not like it's making this stuff up. It's very closely aligned to the source content. Observation is crucial when you're dealing with LLMs. Looking at the tokens going in and out, trying to manage your token budget, trying to see when you're using dynamic prompts, which we are, to pass in context between various stages of the pipeline. You need to kind of see what's going in and what's going out before you actually get your re-rendered content out. It also helps you, manage costs. And with working with LLMs for all this time, I think managing costs is a hugely important thing to get right during development. Some observations. Looking at how responses vary across models. Again, you'd think that maybe the best model was the best. O3 Mini here, which is perhaps OpenAI's best practical model at the moment, actually came in slightly cheaper than 4.0 Mini, and the results were kind of comparable. Dolphin 3.0 free model here actually totally went off on one, wrote way more content, though not always that good at following the instructions. And that's one of the things that we'll talk about in summary. But it is actually about, balancing sort of quality and cost. Context is more nuanced as it comes out. So I mentioned earlier about how we kind of slip the model the whole story. Now, I've tried all kinds of things for that, everything from complete novelization of the episode to just giving it the same transcript but all at once again. And again, you think maybe more is better, but there's definitely a sweet spot. This is the one with the full novelization on the first scene of an episode of Doctor Who called Mission to the Unknown. Not much goes on in that episode, so it's kind of, or in this scene rather. So it's kind of amazing that it's been able to pull out this much. In fact, do we have the scene there? That was it. So the fact that it can pull anything from that is quite amazing. By the last scene, the model seems to have picked up enough context from just the batch processing that even with no extra context at all, it can come up with a fairly accurate summary of the event. As I say, adding more context kind of works, but kind of doesn't. Not nearly as well as I thought it might, which is interesting. So still trying to figure out what the sweet spot of story context is there. So LLMs are creative, sometimes too creative. You get oddities when you're pulling out things like objects and objects like truth or jaw clench or rain or com button, or my favorite actually, which is a good one, which is Superhands' Minecoin project from the Peep Show fanfic that I got AI to write. Minecoin being Superhands' failed crypto mindfulness app, which chef's kiss. But actually, what's interesting there is that some of those kind of expose what the model wants to extract, what it's good at extract, and that can sort of lead you in new directions as well. So after about a year of trying to automate the mythology engine and using frontier language models and forever in beta software that hardly ever bloody works, so has that taught me anything? Yes, it has. Valid structures output is hard. I say again, everything you've heard of about getting structured JSON out of LLMs, it just doesn't work. And for the longest time, the project was stalled on that because you just couldn't get it out. But finding the right ways to get your output out, just use BAM. It's really good. Creativity versus prompt adherence. This is a tough one. You need the LLM to follow your instructions, but you also kind of don't want a very kind of dry, deterministic response. So you've got to kind of balance your temperature with your prompts, with some of the other parameters. And actually even sort of model choice, I think, comes into this. One of the advantages of the Fabular architecture is that each set of extractions can be done by a different model. So you can use the cheap ones for the basic stuff and more expensive stuff for things that need more reasoning. Consistency and resolution. Yeah, every request to a model is effectively stateless. So maintaining consistency across, say, a whole story is really quite difficult. Getting naming conventions on entities is hard. You know, it'll pull stuff out when at the beginning of a story where it doesn't know very much, and will sort of stick to it, later on when it should know more. But I think these things are kind of solvable. They're just kind of issues that need to be dealt with. Context and coherence. Yeah, like we mentioned before, you want the model to have enough context to be able to sort of make a sensible response. But not so much that it starts to kind of flood its memory and then it forgets what it's doing. Similarly, precision versus recall, how much you extract in a single response, particularly when you're extracting kind of entities or whatever. If you extract a whole bunch at once, they're probably more likely to be internally consistent with each other, but it might pick up fewer of them, if you know what I mean. So again, there's a bit of a dance there. And then scaling uniqueness. My so-called UUIDs are not unique at all, but it was important to make them human readable so that an LLM could write them. And beyond that, I think there needs to be sort of more robust UUID stuff in place. So that's something to bear in mind. If you're starting from the bottom up, how do you kind of plan for what would be completely unique IDs? So my advice, break it all down, decompose your tasks, figure out what it is you're trying to achieve with AI. Separate that into specific tasks, which are going to be done in code, which need to be an LLM. Of those that do need to be an LLM, which need expensive, models with high context windows and great reasoning capabilities, and what can you just do with Llama on your desktop, because you can mix and match this stuff. Get to know its quirks. As I say, I mean, it's working with these models a lot. They are often quite different in what they do. Right now, Flash 2 thinking is surprisingly good at creative writing, but almost as good as 4.0, GPT 4.0, but Flash 2 thinking is virtually free. Observe every step of the pipeline. Yeah, when you see, you're seeing things going in and out of the model, you kind of watch what's happening. That's the best way to debug, because LLM code, it won't go wrong like you think it's going to go wrong. The program won't just crash. What will happen is it will start generating stuff that just isn't true, or is just kind of so far off. It's very, very strange at times. So you really need to kind of be clear on what's going into the model, what variables it's receiving, what outputs it's putting out before it gets post-processed. Have great test content. Yeah, you're going to see a lot of it. My God, those 4 stories that I was testing with, I must have generated dozens and dozens of versions of the graphs of those, and so I've gotten to know those stories very well. Again, get AI to write your test content, because it will write it such that it's very entity rich and it's very kind of suitable for the process. And you do it again and again and again and again and again, and you just flush it through until you get it right. And you get used to the fact that there is these trade-offs and there is this unpredictability, and ultimately it isn't a deterministic system. So what's next? We've got 1 minute. Yeah, we've talked about some of this stuff. LLM's sub-symbolic architecture, as known, doesn't really have, subjects, objects, and predicates in there. It's kind of a bit more wibbly-wobbly, timey-wimey. But you hook it up to a knowledge base, and suddenly you've got this kind of graph rag approach where you can convert natural language questions into graph queries, which in our case means that we can express narrative questions as database queries. So text decipher, yeah. Oh, there we go. Yeah, so this is my very, very rough graph rag app. Not brilliant, but what it does, you ask it a question and then it sort of decomposes that into sub-questions. Because most questions people ask, they're terrible questions, they're poorly phrased, they're wrong-headed, and what you need to do is not try and answer that straight away, but break it down into a bunch of questions that might be the thing they're asking and are more suited to the schema that you've got. And then you go and get it to write a bunch of those queries, try all of them, see what's going to work, come back to you sort of and take the results, rewrite them into a nice answer. It's great in theory. In practice, it's very slow, and people have got an expectation set by ChatGPT. But it is the future. So what's next? Timeline and multiverse. So we do have separate events and scenes, but at the moment we don't have a way of reordering them, changing the chronology between them, mostly because that just isn't there in the script half the time. So figuring out ways to kind of do that, automate that is tough. We need extra layers of data. Why not? We can run the same process on the source data again, but this time our schema is all about behind the scenes info, or it's about trivia or retcons or something. We need more ways to consume it. As we've talked about, yeah, what do you do with this stuff once you've got it? How do you make it into a product? We need better ways to fetch context. We need more ways to ingest this stuff. And ultimately, I would love to hear what you guys would do with this. On GitHub, you will find all the code for Fabula, along with some pre-graphed output for Doctor Who, Star Trek, Peep Show, and The West Wing. I would love it if you tried it out, left feedback, or even would like to contribute. I've been Mike Atherton, and thank you for your time. Yeah, yeah. Do you see a future where we can do this during the production of stories with writers rather than after? Yeah, kinda. In that it is an ongoing process. As I say, it doesn't. I mean, if I had any sort of criticism of the mythology engine idea, it was very much somebody coming in after the fact and doing a sort of post hoc analysis on the story. And that's, you know, that's how people review things. But if you've got a story that is unfinished, that is happening, unfolding in real time, a scene at a time or a moment or a time, then yeah, I mean, you could be doing this sort of on an ongoing basis, essentially, which is almost an answer to that question. Did you observe any model collapse, or would you like to, from feeding LLM outputs to the LLM? David Lynch would have nothing on that stuff. Indeed. Yeah, sometimes. As I say, when it goes wrong in funny ways. I had a thing this morning where I was trying to do map reduction on a screenplay, trying to mess with this, how you get enough context in. It totally gave me a summary of a story it had written itself. Quite happily, the code worked. It was all in the right like JSON format and everything, but it wasn't the story that I'd put into it. It was like something else entirely, which is kind of weird, isn't it? But yeah, things like that are going to happen, and you got to kind of mitigate against them. There's ways to do it. How do you determine what success looks like? Yeah, this has always been my problem, really. I just do it for the hell of it, you know. If I've done it, that's success to me. I don't know. I feel like there's lots of ways that where this could go. I think you can use graph science to, you can do things like community detection to determine storylines. You can do link prediction to kind of anticipate where stories are going to go. You could even, find ways to kind of construct new narrative pathways within an existing story. So you could rewrite the story from someone else's perspective, for example, and it still be true because it's still based on all the source information. How do you find balance when a different LLM goes quirky? I'm not sure what that means, but yeah, as I say, like, well, I mean, the LLM has gone quirky and has pulled out lots of metaphysical concepts as objects, and that's super interesting to me. And what it tells me is that my 4 primary entities aren't enough, and we perhaps need some more granularity there to be able to capture some of these things that the model really seems to want to capture. Thank you.
Wow, what a day. Thanks so much, Mike. So you join us at an exciting time as our information architecture capability continues to grow across government, the wider UX community, and as part of future technology. A massive thanks to our speakers, fellow curators, and volunteers that help make this day happen. Let's keep talking. And we'll also be heading to the Hoop and Grapes down the road for a quick drink, and we'll be about here to have a chat afterwards. We need to leave the office around about 9:30. Thanks so much, everyone. Thank you.
I should have touched the laptop. I've never really touched the keys after my touch.
So get in touch and enjoy your holiday. Thank you.
Are you thinking
Hello.